All right, how we doing? We are going to be doing number 13 for statistics today. Number 13, two-way tables worksheet. Okay, this is what it looks like. It's a teacher-made assignment. All right. So, I'm going to adjust my monitor a little bit over here. Okay, sorry, should have done that ahead of time. All right, so two-way tables, independent practice worksheets. Complete all the problems after a series of matches between a school's teams and their rivals. The school secretary analyzed the relationship of the number of wins and matches played. The results are summarized in a two-way table below. All right, so we have some various sports over here in this column. We've got boys wins, girls wins, total wins over here in these columns. All right, so the question number one is, how many total wins did the school's volleyball team register? Now, to answer this question in number one, we're going to have to fill in this table a little bit. All right, so this requires you to interpret a two-way variable table. So I would like to invite you to pause this video right now and just give this a shot. Okay, see what you got. All right, so because you control the video experience, right? You can slow me down, you can speed me up, you can skip ahead, you can pause. But I encourage you to give this a shot. You'll learn more if you give it a shot on your own, kind of without that support. Just try to make even guesses, because even when you look at it and say, I don't know how to do it, the question mark in your head that will happen when your brain doesn't know how to do this will you'll open the file cabinets in your brain for where to put this information, so that when I do show you, boop, you'll be able to know right where to put it in your brain. All right, pause it. All right, through the magic of video, you paused it, you gave this a shot. You know, So this first column, so hopefully you know that right here in this box right here, I'm going to have to put in the total, right? I'm going to have to put in the total. See how it says total there? I'm going to have to add up these three numbers. So I'm going to go to my calculator. I'm going to turn it on. Sometimes my calculator's a little slow turning on. There we go. Clear that. All right, so 23 plus 40 plus 15. All right. So we add those three up. We got 78. So what goes in this box is 78. And I'm going to do the same thing here. I'm going to have to girls wins. I'm going to add up all the girls wins, 18, 10, and 25. So 18 plus 10 plus 25. 53. All right, so I got 53 over here. 53 total girls wins, 78 total boys wins. I can now fill in this box right here. I can fill in this box right here, which is total wins entirely. So I have to go and add these two things up. The two numbers I already found, 78 and 53, I'm going to add those two up to find what goes in here. All right, so 78 plus 53. 131. So there was 131 wins total. All right. Now let's start filling in these boxes here. Hopefully you kind of saw that to fill in this box here, you're going to have to add 23 with 18. So 23 plus 18, that's 41. So I'm going to go ahead and put a 41 in there. And then for this one, I don't even need a calculator for this. This is pretty easy, right? 40 plus 10, that's 50. 40 plus 10, that's 50. And then we could do this one too, right? This would be 40, right? 15 plus 25. 15 plus 25, 40. Now, if I added all these things right, if I did everything right, then 41 plus 50 plus 40 should equal 131, right? So that's a way to check my work. It should work both ways, on the column and on the row. 40, there we go. 131. See how that, when I add these three up, it's 131, which is the same as when I add these two up. So that kind of checks my work. That tells me I did everything right, and now I can start answering some of these questions, right? Now I can start answering some of these questions. How many total wins did the school's volleyball team register? Well, I go to total wins did the school's volleyball teams register? So there's volleyball. The boys won 23. The girls won 18. Together, that's 41. So the total wins of the school's volleyball teams is 41, right? There's the total wins of the school's volleyball teams. And question number 2 asks, how many more wins did the boys' teams have than the girls' teams? Okay, well, boys' teams total is over here. girls' team's total is over here. So I'll do 78 minus 53, right, to find out the difference of these two numbers. I'm going to find out the difference means subtraction. To find out the difference, I'm going to subtract. And so 78 minus 53 is 25. The boys won 25 more games than the girls did. All right, the boys' teams versus the girls' teams there, given that data. The data is summarized in a two-way table for the number of boys and girls that regularly drink water, lemonade, or soda at lunch. Okay, so we're now working with a new table here. This is about water, soda, and lemonade. All right, so now they're going to ask, what is the percentage of boys that regularly drink water? Well, again, just like the last problem, we're going to have to fill in these empty boxes here in order to know what the percentages are. So maybe you want to give this a pause and see if you can do it. All right, I just showed you how to do the one up above. Hopefully this will be a little easier. So pause me and give that a try, all right? Okay, you pause me, and through the magic of video, I'm back, and let's do this. So to fill in this one box here, right, I'm going to add these columns together. I'm going to find out all the different boys that, so this 45 number represents the number of boys that drank water. This 50 represents the number of boys that drank soda. This 42 represents the number of boys that drank lemonade. This 32 represents the number of girls that drink water, and so on, right? This 38 is the number of girls that drink soda, and this 32 is the number of girls that drank lemonade. These are the total. This 77 is the total students that drank water. This 88 is the total students that drank soda. This 74 is the total students that drank lemonade. So what's going to go in here is the total boys, right? We're going to total up the boys. So to do that, I'm going to have to add 45 with 50 with 42. 45 plus 50 plus 42. That's 137. 137. And there I'm going to add up the total of girls, right? 32 plus 38 plus 32. 32 plus 38 plus 32. 102. All right, 102 goes in here. And now I'm going to add these two things to find out what goes in this box, right? Then add up all the boys and the girls together to find out what goes in that box. So 137 plus 102. 239. 239 can go in that box right there. And to check my work, I'm just going to add up these three just to make sure I did everything right. Okay, so 77 plus 80. Oh, I didn't, not 7, but 77 plus 88 plus 74. That's 239. All right, so everything works out, all right? Okay, so now that we've got our two-way variable table done, we can start talking about these percentages. And I want you to remember that, this is important. Percentage equals part divided by whole times 100. Oh, not times 1,000, times 100. Okay. Percentage is going to be equal to part divided by whole times 100, right? Why times 100? We times it by 100 because if we just do part divided by whole, we'll get a decimal percentage out of 1, okay? If we just do part divided by whole, we'll get a decimal percentage out of 1, and then we would need to then multiply that percentage by 100 to find out what the percentage is in like a real number. So let me give you an example. If the part was 50 and the whole was 100, right? Hopefully you all know that would be 50%, right? So if I just do 50 divided by 100, what do I get? I get 0.5 or just 0.5, right? So I would then need to multiply 0.50 by 100 in order for it to be 50%. So you see why that works? So it's part over whole. If the part is 50 and the whole was 100, and I just divide it, I'm going to get this decimal out of 1, which maybe if you can know how to interpret this, you'll immediately see this and you'll be able to move that little decimal place over 2 points, 2 places, and then you'll say, oh, that's 50%. I just, I throw in the times 100 just so you know exactly what to do, okay? So that's a little bit of notes there. All right, what percentage of boys regularly drink water? Okay, so what's the percentage of boys So we got to read these very carefully. Sorry, the sun's in my eyes. It's morning time. What percentage of boys that drink water, regularly drink water? So what's the percentage of boys? Of boys. So of boys. So what's my part? My part is the boys that drink water. What's my whole? Of boys. All right. My part is the boys that drink water, and my whole is of boys. Right. Of boys. How many of those boys drink water? Okay. So my part is boys that drink water, which is 45, and my whole is that was neat. It did the little division thing. My whole is the total number of boys, right? Because it's of boys. All right, and then I times that by 100. Woo! Oh, I like this. I like that it does a little math doohickeys for me. So let me go to my calculator for this. All right, so I'm going to say, well, first I'm going to put this in parentheses. I want the calculator to do the division first, although because we're not mixing any addition or subtraction in there, it won't matter. So actually, I could have just done all this one line, but it's good math hygiene to just do parentheses when you when you want certain operations to happen first. Okay. So when I press enter here, what do I get? I get 32.84. Okay, I get a kind of an irrational decimal there. Do it tell me to round? Yes, round answers to the nearest tenth of a percent. Okay, so I want to round to the nearest tenth, and the tenth place is the unit right behind the decimal point. That 8 is in the tenths place. I want to round to the nearest tenth place. So to do that, I need to then look at the hundredth place, which is the next one over. And I see that there's a 4 in the hundredths place. There's a 4 in the hundredths place. Now 4 is less than 5. So that means I just keep everything the way it is. I drop the 4, all this disappears. This just becomes 32.8. Okay. Had that 4 been a 5 or more, I would have rounded that 8 up to a 9. But since it's a 4, it's 32.8. 32.8. 32.8. Feeling good about that? Feeling good about that? All right. Oh. Math teachers are crazy about units. So you got to put in that percentage sign. All right. Got to put in that percentage sign. All right. So next is, what is the percentage of girls that regularly drink water? What is the percentage of girls that regularly drink water? So what is my part? What is my part? Think about this. Maybe you want to pause me and give yourself some thinking time to do the part and whole part on your own. Yeah, because if you do this on your own, you're going to learn more. If you just wait for me to tell you, you won't learn as much. You'll feel like you're learning a lot, but you won't quite learn quite as much. All right, I'm hoping you paused me. And give yourself some time to think about this. You owe it to yourself to give yourself some time. So the part is girls that drink water. All right, so let me find girls that drink water. Right here, that 32. That 32 is the girls that drink water. What's my whole? My whole is of girls, right? What is the percentage of girls that regularly drink water? So of girls that regularly drink water, what percentage of the girls that regularly drink water? Yeah, let me say it again. What is the percentage of girls that regularly drink water? So we want the part is the girls that regularly drink water, and the whole is of girls. Okay, so my total girls was 102. 102. So I got to times this by 100, and then I go to my calculator, and again, parentheses is just good math hygiene. You don't need it in this particular case. It won't matter, but I like you to get used to it because that way you won't have any mistakes when you do have mixed operations. 31.37. Okay, so we're going to round to the nearest tenth. All right, so 3 is in my tenths place. To round to the nearest tenth, I have to look at my hundredths place. I look at my hundredths place, I see a 7. A 7 means I need to round up. 7 means I need to round up, so that 3 becomes a 4. So this becomes 31.4. All right, 31.4 percentage sign. All right, people. All right. Try this next one. Pause my loud mouth and give this a shot for yourself. All right. All right, you unpause me. It's the beauty of video. I don't have to actually give you the 30 seconds of wait time. You can just pause me and unpause me at your desire. So, what's the percentage of girls that regularly drink soda? Okay, so my part is girls that drink soda, right? Girls that regularly drink soda. So I have to find that in my table. There's the soda. There's the girls. 38. 38 is my part. All right. Now, what's my whole? What's my whole? Remember, percentage equals part divided by whole times 100. So my whole is, what is the percentage of girls? Of girls. Of girls is total girls. 102. 102. Oh, just so you know, when I did this little fraction, I had to press the right arrow to get over to the side there in case you were having trouble with that. I didn't know how to do that. So just I'll have to delete this, but yeah, let me delete everything. So I do 38, I do 38, I did the divide slash, right, and I did that, and then I do 102, and then I want to get it to the, off this, so I'm going to press the right arrow, and it does that, all right? So, times 100, all right, and then that's going to be equal, we're going to go to our calculator for this. Let me show you that you don't need to do the parentheses in this case. Because we're only mixing multiplication and division together, which means we don't need parentheses, but I advise you to do it. I advise you to use the parentheses. So I'm going to do it. So see how it turns out just fine. But this is just good, what I call math hygiene, because I want you to think about this operation as if it happens first, and then this operation as it happens next. And then that way, when you do have mixed operations, you won't it won't goof up, right? So by using the parentheses, you're kind of forcing the calculator to follow just follow it the way you want it to happen. So we're rounding the nearest tenth again, right? All right, so the nearest tenth, 2 is in the tenths place, 5 is in the hundredths place. That 5 in the hundredths place tells me I have to round that's 5 or greater, which means it tells me I have to round my tenths place up. Okay, so that 2 becomes a 3, 37.2, 37.2, 37.2. Gotta have that percentage sign. All right. What is the percentage of boys that regularly drink soda? Pause me and try it, okay? Great. All right. Hopefully you pause me. Hopefully you're giving yourself that learning experience. Again, you're gonna feel like you're learning if you're just watching me. But it's just like watching someone else lift weights. You might be able to pick up some technique. You might be able to pick up some ideas, But you actually got to do. Sometimes you got to actually pick up the musical instrument or pick up the weights to learn the skill. Right? You're not gonna learn a foreign language by listening to someone else speak it. You're gonna need to do some speaking on your own to pick up the skill. Does that make sense? So the part is boys that regularly drink soda. All right, the part is boys that drink soda. So what percentage of boys that regularly drink soda? So boys that drink soda, that's 50. What's the whole? The whole is of boys. Of boys. So that's 137, right? We have 137 total boys. What percentage of boys drink soda? So I'm going to multiply by 100. Go to my calculator. 50. Oh, yep. Math hygiene. 50 divided by 137 times 100 is that. Oh, and let me show you what happens if you don't use the times 100. All right. So if you don't use the times 100, if you forget what that, to do that, you'll get a number that looks like this. This is a decimal out of 1. So what you could just do is you could just move this decimal place over in your head 1, 2 places, and you're essentially getting this number over here, right? So I teach it as times 100 just so it's more straightforward and easier for you. But if you don't want to do that, you don't have to do that. If you can move that decimal place over 2 points and you're cool with that, do it however you feel comfortable. I like to teach it this way because that way it gives students a final response a little bit easier, but it requires you also to remember to multiply by 100. And I want to show it to you both ways so that you know how to interpret it if it doesn't look like that and if you've forgotten the times 100. All right, so 36.4963. All right, we got another irrational here. We're rounding the nearest tenth. There, 4 is in the tenths place. There's a 4 in the tenths place. I go over to the hundredths place, and there I see a 9. That 9 is 5 or greater, which tells me I got to round that 4 up. So I got 36.5. 36.5%. 36.5%. All right. What is the percentage of students that regularly drink water? All right. What is the percentage of students that regularly drink water? You know what I'm going to say, right? Pause the video here so that you get a chance to try this, all right? All right, great, great. So, part over whole, okay? What's the percentage of students that regularly drink water? So, students that regularly drink water is my part. Students this time. Students that regularly drink water. So, students, water. So, students is going to be these numbers here, right? Because students, both boys and girls, are students, right? So, students that drink water is 77. Students that drink water is 77, right? That's the boys that drink water and the girls that drink water. So it's 77 total students that drink water. And what's my whole? What's my whole? That's the of the students is of all the students, right? That's 239. 239. Out of 239 students, 77 of them drank water. I'm going to click the right arrows to get out of this, and then times 100 equals, I'm going to go to my calculator. 77. Oh, math hygiene. 77 divided by 239. I want that done first. Then I want to multiply that by 100. All right, there I go. 32.21757322. Round to the nearest tenth. All right. My 2 is in my tenths place. There's a 1 in my hundredths place. The 1 is less than 5. Therefore, the 2 stays the same. 32.2. 32.2%. 32.2%. All right. And what is the percentage of students that regularly drink soda? What is the percentage of students that regularly drink soda? You know it. Pause me. All right, you pause it. What's the percentage of students that regularly drink soda? Well, it's part over whole, right? Percentage is part over whole. So what's the part? Students that regularly drink soda. Okay, so I'm going to go to my table. Students that drink soda. That's going to be the 88, right? Because that's the boys and the girls that drink soda. That's 88. 88 is my part. What's my whole? What's the percentage of students? Of students is total students. Boom. Divided by total students, 239. 239. So this is the percentage. It's going to be the part is students that regularly drink soda, and this is of the students as the whole. 88 over 239, right arrow, times 100 equals, that's where the math machine comes in handy, 88 divided by 239 times, whoa, did someone shout out, Mr. Salt, you typed it in wrong. Thank you, keeping me honest. 239 times 100. I still did it wrong. Look at that. All right, try again. Take 2. I can do that, right? It's my video. I can do what I want. There we go. 30. Okay, so here we go. So we now have the percentage of students that regularly drink soda. It's going to be, let's see, I got in the tenths place, I'm going to round to the nearest tenths. In the tenths place, I have an 8. In the hundredths place, which is what I got to look at to see where that 8 rounds up, I see that there's a 2. 2 is less than 5, therefore the 8 stays 36.8. 36.8%. Kaboom. Okay, is this the last page? No, this is the last page. All right. So below, you will find an incomplete two-way table that shows the number of girls and boys that were passing economics and science. There are a total of 72 boys and 72 girls taking economics. There are 78 boys and 60 girls taking science. Okay. Oh, I'm going to have to I'm going to have to use these clues to fill in this table. See how that goes? All right. Should I invite you to do this on your own, or should I just do it? Well, it's up to you. You can either pause me or just watch me, because I don't know if we've actually. In the last video, I showed you how to do this, but I haven't showed you how to do this in this video yet. So let me just let's puzzle this out. Okay. First clue: there are a total of 72 boys and 72 girls taking economics. Okay. So I know there's 72. Oh, okay. So listen, I know there's 61 boys passing economics, and I know that there's 72 boys taking economics. right? Then I could find out how many are failing economics with a little calculation, right? I know that there's 72 total boys taking up economics. That's that first clue. I see that there's 61 boys passing economics. So 72 minus 61, the difference between these two numbers is going to be the number of boys failing economics, all right? So that's 11. 11 boys are failing economics. I can do the same thing with girls and economics, right? 72 total girls passing economics. I'm sorry, 72 total girls taking economics. 67 of those are passing. So 72 minus 67, the difference between these two numbers is going to be the girls that are failing economics. So there's goes a 5 goes in there. This little box is easy to total up, right? I just add these two. So 61 plus 67 is 128. And this game is a little bit like, dominoes. Once you start knocking a few down, they all start falling into place, right? So, and this little box here is 11 plus 5, right? This is the total of all students failing economics, right? Total of number of students failing economics. So 11 plus 5, well, that's 16. Well, I shouldn't talk and use a calculator at the same time. Apparently, I'm not good at that. All right, 16. And what goes